So with this integral, first thing to notice is that we have an even function. So we know how to integrate things between minus infinity and infinity. So we can write this as I equals half of the integral from minus infinity to infinity of cos mx over a squared plus x squared dx. And the trick we know is, of course, that this is just the real part of e to the imx, which we know how to integrate. So I is half the real part of e to the imx dx over a squared plus x squared. Okay, so the first thing to do is to check that the integral exists so that we can use this technique, and that is our phi is 1 over a squared plus x squared, and that surely as x goes to infinity tends to 0. So we can use Jordan's lemma. The contour we're going to use, always draw your contour, is the semicircular one, semicircle of radius r. Label your axes, and so we're going to consider this contour integral limit as r goes to infinity of e to the I mz dz over a squared plus z squared. So this is going to give us along here, as r goes to infinity, we will get something like the integral we want, not quite the integral we want. I'll just write it out in this case. We can actually, well, okay, normally what we'd do is write out this bit here, but because of Jordan's lemma, we can actually skip that bit and simply just write down this as the answer. So basically we've got e to the I z, sorry, e to the I mx over a squared plus so this, of course, is going to be this 2 pi I times the sum of the residues. So we need to work out where the poles of this are. So e to the I mz never has any problems except at infinity. This obviously is going to have poles at z equals plus or minus a. So we have a pole inside the contour here. So we need to work out the residue. Residue at this thing here. So anyway, applying this result here, we've got I is half the real part of this, which means it's half the real part of this, which means it's half the real part of 2 pi I times the residue, so real part of all of this, times the residue of 1 over z squared plus a squared at IA. So this is giving us the p over q dash. That's going to give us 1 over 2z or 1 over 2ia. Oh, sorry, I forgot. We also have this on top, so it's e to the imz. So p is e to the imz, and q is z squared plus a squared. So our residue is going to be substituting in, it's e to the minus ma. So writing all this out, it's okay, well, I'll use this half to cancel this 2 here. I can see I'm going to get this I is going to cancel the 2ia at the bottom here. So in the end, I don't actually need the real bit anyway. It's going to be real anyway. So I just end up with 2a from these 2's here. Cancel pi on the top. And on the top, I've got from this substituting in minus ma as my final answer.